Hi everyone. Today we're going to be learning about seasons. If you don't have these materials, your science notebook, your pencil, and color pencils, please pause the video and gather those. Otherwise, let's jump right in. As always, I want to start out with a quick vocabulary match. So here's our bell ringer for today. Just number 1 to 7 in your science notebook, maybe just in the margin. And then I want you to choose the correct definition or meaning that matches with each of those vocabulary words. Go ahead and pause the video and do that now. Let's take a look at our bell ringer answers. So, an eclipse. An eclipse occurs when an object in space moves into the shadow of another object. Remember, eclipses are all about shadows. For 2 and 3, that's our umbra and our penumbra. Remember, the umbra was the darker inner part of a shadow. We said that that shadow cone gets smaller as it moves away from the object making the shadow, whereas the penumbra is that lighter outer part of a shadow, which gets bigger as it moves away from the object making the shadow. We had two really types of eclipses, which a partial and a a total. Number 4 and 5, a total eclipse. Remember, a total eclipse requires perfect alignment. That happens when an object moves completely into that darkest part of the shadow, the umbra. A partial eclipse, on the other hand, is not perfect alignment. It's just kind of aligned. And so a partial eclipse is going to be the type of eclipse that happens when the object moves into the penumbra, or maybe only partially into the umbra. And the two most important types of eclipses, and I wanted to focus on total eclipses, so a total lunar eclipse. A lunar eclipse is a type of eclipse that happens, remember, when the moon moves into the Earth's shadow and we get that reddish moon. And a solar eclipse is a type of eclipse that happens when the Earth moves into the moon's shadow. And remember, the moon shadow is quite a bit smaller, so these are actually a bit more rare for us to be able to see. But that usually gives us a disk of the moon with some light that shines out from around it. Let's look at some objectives for today. So remember, we're going to be studying some features on the globe and climate zones, but really we're talking about seasons. So today, I want you to see if you, at the end of the lesson, can identify the 4 major season divisions and generally compare their temperatures. Generally, I don't want something specific, just be able to give me a relative comparison to one another. I also want you to be able to compare these terms latitude and longitude and know the difference between them. You're going to need to be able to label features on a model of Earth, and we'll take a look at a model of Earth for you to be able to do this. An equator, you'll need to be able to label the equator, the northern hemisphere, the southern hemisphere, Earth's axis, and the north and south pole. I also want you to be able to explain Earth's equator. Let's try that again. I also want you to be able to explain that Earth's equator receives more concentrated sunlight while the poles receive less concentrated sunlight, and that's because Earth's a sphere. And finally, be able to list and describe the basic characteristics of Earth's climate zones. Here we go. So when we talk about seasons, this is not new to you. Most of you, I believe, understand that we have 4 different seasons over the course of 365 days or 1 year. Right now, we are in this season called spring, and so spring generally is March, April, and May. Spring is characterized by these warm temperatures or moderate temperatures, and so after spring, we're going to move into one of your favorites, summer. So spring was March, April, May, then summer begins in June, July, and then into August. Of course, these are the hottest months. This is when we expect to have the highest temperatures. After we go to summer, we of course have autumn, also called fall. Called fall because the leaves fall from the trees. Autumn is characterized once again by mild temperatures. It can still be warm, but we start to get a mixture of some cooler temperatures as well. And so autumn is of course going to be September, October, and November. Winter, which is the final season, is of course going to be December, January, and February. These are generally our coldest months. And so these are the seasons. I do want to point out that we happen to live in a place that experiences seasons like I've just described, but not all places do. There are many places on Earth that simply do not have these seasons. And even if they do have these seasons, they may not happen during the same months, or the temperatures might not be as drastically different as they are here for us. So we do happen to live in a place on Earth that experiences seasons. So interestingly, I just want to really briefly look at this image. I do want you to know that these different seasons, we can actually see these from space. So this is actually a satellite orbiting Earth. It took some pictures that were stitched together. And if we look at some pictures from December, all of this white stuff, this is going to be some snow and ice. And so we can see that in December, winter, we have a lot of that. Notice that as we move into March, we pay attention, we can see that there's less. That looks like that snow and ice has moved further north. If we go down into June, which would of course be our summer months, we still have some snow and ice, but it looks like it's going to be mostly down up near the pole, at each pole. But we can see that that ice has sort of migrated further north again. And then we get into December, remember that's fall, excuse me, September, remember that's fall, and we can see that ice and snow is beginning to move back down from the poles and travel further down. So when we talk about seasons, this is what we're looking at. We're looking at this change in temperature, okay? And this can even be seen from space. So this is the big question for us. Why do we have different seasons? I want you to pause the video and I want you to stop and think. I want you to see if you can come up with a reason why you think we have different seasons. Why is it sometimes much colder for months at a time, and other times it's obviously much, much hotter? Once you think you have an answer, I want you to go ahead and restart the video. So this might be a particularly helpful diagram for many of you. So this diagram shows us that Earth's orbit is not a perfect circle, right? This is something, it's almost oval shaped. It's called an ellipse, okay? So let's take a look. So if we have an oval shape for Earth's orbit, remember orbit is a path around the sun, then that necessarily means that at some points during the year, the sun is closer to us, and at other points of the year, it's further away. And many students often think, I know that Earth has an orbit that is elliptical, and I believe that's why we have the seasons, because it makes sense. You might think if I stand really close to a campfire, a source of heat, the sun produces heat. If I stand really close to it, then I'm going to be warmer. That might be summer, right? And when I am further away from it, if I stand further back from the campfire, then I'm going to be colder, right? That might be winter. Even though this makes a lot of sense, it's actually wrong. This is not why we have the seasons. And here should be the evidence that you need. So in January, in the northern hemisphere, okay, so here's January when we're here. In January, which we would expect to be the coldest months, right? That's right in the middle of winter. It says here that Earth is about 91 million miles away. Okay, so let's compare over here. In July, we would expect that to be in the middle of summer, some hot months. It's 94 million. So we are closest to the sun in January, and we're furthest from the sun in July, and that doesn't make any sense. So if you're thinking that, using our campfire analogy, that sometimes, that we have these seasons because when we're closer to the sun in our orbit, then we're warmer and that's summer, that's completely wrong. In fact, it's the exact opposite. So we need to explore this a little further. So it is true that Earth's orbit is elliptical. It's not a perfect circle. However, that is not what causes the seasons, because remember, in the winter, we're actually closest to the sun. So some terms that we're going to need to understand the seasons, and these are terms that we saw very briefly earlier in the year, and I think you saw them in 5th grade, is latitude and longitude. These are very simple to understand, okay? So latitude and longitude, we're talking about two different types of lines, and we have some lines that go side to side. These side-to-side lines, these are called lines of latitude. And then we have some lines that go up and down. These are imaginary lines that we draw on Earth. These up and down lines, we call those lines of longitude. But what we can do is we can combine these lines of latitude and lines of longitude, these imaginary lines, and we can sort of project them on Earth and we create a grid. This allows us, this grid, much like a coordinate plane in math, is going to allow us to find points on Earth, to locate specific locations. It gives us a mathematical way to tell where we are. Okay? So lines of latitude, latitudes are the side-to-side lines. Sometimes we call these horizontal. And lines of longitude, these are the up and down lines. Sometimes we call these vertical. And together, lines of latitude and longitude make up a grid that we can use to find locations on Earth. Okay, so this is something also that I believe I have briefly mentioned with you. I think we did a reading on it. I want you to stop and think, and you're going to need to pause the video. I want you to look at the diagram. And can you name each of these divisions or features on this model of Earth? A good place to start here is number 3. So pause the video and see if you can tell me what each of those things is. Just restart the video when you think you have your answer. You don't need to write anything down. Okay, so we looked at lines of latitude and longitude, and those are, we said, are imaginary lines that we sort of project onto Earth. Well, really, some of these other things that I need you to look at are also somewhat imaginary. These are sort of features on models. So if we look here, I told you to start at number 3. This line that seems to, it's an imaginary line that divides Earth in half, we call this the equator. Okay, so we find the equator here in the middle. And the equator, it divides Earth in half, and the two halves that it creates are hemispheres. So a hemi means half, half of a sphere. So we have the upper half and the lower half. The upper half, or the northern half, we sometimes call the northern hemisphere, and the lower half, if we go south of the equator, we'll call the southern hemisphere. Now, we also know that Earth rotates, and we've said that it rotates on an axis. I want you to think of an axis as being sort of an imaginary rod passing through the center of Earth, similar to like a wheel and an axle. And this is, if we had this imaginary rod passing through Earth, this would be its center of rotation. It rotates around this axis. Of course, there is no rod going through the center of Earth, but it's a good way for us to imagine what is happening. And when we look at the axis, the place where the axis intersects with the Earth's surface in the northern hemisphere, where it sort of exits, we call that the North Pole. And then when we find where the axis exits or intersects with the Earth's surface below the equator, we call that the South Pole. All right. So we need to keep in mind here we have our equator, which divides the Earth into the northern and the southern hemisphere. We have our axis, which is our center of rotation. Think of an imaginary rod. And where the axis intersects with the surface, north of the equator, that's our North Pole. And south of the equator, that's our South Pole. It's really strange to move from, I know, it's really strange to move from looking at a model of the Earth to looking at 2 flashlights, okay? But I think this is going to help us a bit. So let's start out here. We have 2 flashlights that we're shining toward a wall at the same time. So both flashlights, I need you to keep in mind, flashlight A and B are giving off or producing the same amount of light, and they are exactly the same distance from the wall. The only difference between them is flashlight B is pointed straight at the wall. It is perpendicular. It is perpendicular to the wall. Flashlight A, on the other hand, is tilted in relation to the wall. Okay, so flashlight B, if we look at the light that it produces, and I would encourage you, if you have a flashlight at home, to very quickly just go and you can check out, make sure the science works. Some of you have played with flashlights a lot. I know I have, and you know that this is true though. So flashlight B that's not tilted, its light and heat are going to be concentrated into a really small area. Remember, same amount of light, smaller area, so we'd say that's concentrated. Flashlight A that is at a tilt, its light and heat, it's going to produce it's going to have a much larger area that the light and heat from it are going to be spread out over. We'd say this is less concentrated. So when we tilt that light, we end up with less concentrated light and heat. When it's not tilted, then we have concentrated light and heat. So let's see if we can apply that to what's happening here on Earth. So Earth, of course, is a sphere. Okay, a sphere meaning a three-dimensional object that it's round, and we can take our flashlight example, and if we have light coming from the sun, coming to the equator, light that is striking the equator here on Earth, that is going to be direct or concentrated. You're not going to find, this is like the untilted flashlight. It's going to be very direct light. As a result, you're going to have you're going to have some differences here. Now I want to move from here at the equator up to the poles. Okay, so the light up here, because Earth is a sphere, we can see that that light gets spread out more. So here it's not the light source that we're tilting, it's because Earth is round that we end up with this light and heat striking in this way. So we have less concentrated, in some ways it's weaker light and heat that are going to strike here at the poles. So the light at the equator is very concentrated. It's more direct. It's, I guess, stronger would be an okay word. And we have light here at the poles that is going to be less concentrated. It's going to be weaker, and it's going to be a little bit less direct. So, and then of course, as we move from here to here, we have different variations. So as we move north from the equator, the light gets weaker and weaker and weaker and weaker and weaker until we get all the way to the North Pole, where this location on Earth would be where it would get, we would have the weakest light, the least concentrated light. And once again, this is just because Earth is a sphere. So we've talked, and I know you talked in 5th grade about climate zones, okay? So climate zones, we have 3 basic climate zones. We have tropical, temperate, and polar. So let's see how this light being spread out, because Earth is round, creates these 3 climate zones. So tropical, we find at the equator. Tropical climate zones, it's always hot. It's generally summerish here. So at the equator, in this climate zone, really from about here to here, we're going to have summertime conditions always, not really seasons. Okay, and this is in a tropical climate zone. And once again, that's because of the sunlight being very direct, not tilted. Let's head up to the poles. So notice that we have a polar climate zone here, and also down here we have a polar climate zone. We're going to have cold and dry climates near the poles, and that's because that light is spread out. It's less concentrated, so that's going to cause a temperature difference near the poles, and this is because Earth is a sphere. Okay, and then in between we have these above and below the equator, we have temperate climate zones. Okay, temperate means medium or moderate. So here is where we're in these temperate climate zones. This is where we're going to mostly experience seasons the way that you think of them. We're going to have hotter summers and colder winters. Now we have that. We're going to have these temperate climate zones above and below the equator. You, of course, live in a temperate climate zone. All of this, these different climate zones are simply caused by the sunlight being direct and concentrated here, and it being the light near the poles being spread out, being weaker, less concentrated. Okay, so those climate zones. It's going to help us understand what's happening with the seasons here on Earth. This is a good map that will sort of show you where the different climate zones are, and we can see here. So here's our equator, really up to, this shows 30 degrees here, and they're rounding. This is going to be everything in this band of green is going to be a tropical climate zone, which means it's always summer-like. It's going to be hot mostly. We can see that Florida, if you've ever been to Florida, Florida would be within that tropical climate zone, according to this map. Now we're somewhere in here, okay? You can see that we are in one of those 2 yellow temperate climate zones. These places on Earth are all within temperate climate zones. And so these are places that are going to experience those hot summers and those cold winters. And then when we move to the poles here, it's in like this pinkish reddish color. Notice we have 2 polar zones, and this is always going to be winter-like conditions, okay? So wherever we see the red, these are always going to be, these polar zones are going to be winter-like, and it's going to be cold there for the biggest portion of the year. Okay, so the last thing that I want to talk to you about today is the fact that Earth is tilted on its axis. So in all the pictures I've shown you till now, I've shown you Earth being tilted I've shown the Earth being straight up and down, but Earth is tilted on its axis. It's the last thing I want you to keep in mind for today. All right, so here's your assignment. Um, and I want to have you think about this in terms of if you're doing it online or if you're going to be doing it off USB. So your assignment for today is you're going to take a small quiz. As always, you can use your notes in your science notebook. You can use any of the videos that are posted on Google Classroom, and you can take the quiz as many times you like. I'm only going to record your highest score. So if you have internet and you're working off the internet and watching this video on the internet, you will find on Thursday or today, you're going to find a link that's going to take you to a quiz on Quizzes. My recommendation is you follow that link and you type in the game code, then put your full name. Now, of course, some of you are going to choose to sign directly into Quizzes. Either way will work. Okay, so use your notes or the videos many times you like and look for the link. Now, if you're working on a USB drive, the quiz is already on the USB drive. You just got to click it to open it. You're going to write your answers on notebook paper. You, once again, can use your notes. You can even look back at those videos that are on your USB. I also put some notes for the moon. Those are my notes for you to be able to look over if that would help you. When you finish, I want you to write your name on the paper, and I want you to ask an adult to take a picture of your quiz and text it to this area code 828-506-3221, or it can be emailed to rcrawford@jcpsmail.org. Either way, I will get you, I'll get your paper and I will be able to give you some feedback on that, and then we'll go from there. So ladies and gentlemen, I think we're done for now. So until next time, stay curious.